Okay, in our previous video we looked at lines and transversals, and in this video we're going to look at parallel lines and transversals. So here I have a picture of two parallel lines cut by a transversal. I know they're parallel because they have these two parallel line marks on them. And I'm going to start out with something called the parallel lines postulate. And the parallel lines postulate says if two parallel lines are cut by a transversal, which is what we have right here, two parallel lines cut by a transversal, then all pairs of angles formed are either, and this should remind you of a postulate that we had in the last video, the intersecting lines postulate. If two parallel lines are cut by a transversal, then all pairs of angles formed are either congruent or supplementary. And we're going to make use of this in just a few minutes. So the corresponding angles postulate, that's one of the first postulates that we're going to look at having to do with parallel lines and transversals. And actually, before we look at that, I'm going to take, since it's going to kind of take the same form as the parallel lines postulate, and in particular, this phrase right here, if two parallel lines are cut by a transversal, that hypothesis part of the postulate, we're going to be seeing this a lot, and rather than having to keep writing the same thing over and over and over again, we're going to use a kind of abbreviated version of that. We're going to say 2PLCBT. And that's just going to stand for two parallel lines cut by a transversal. All right, so now I can write my corresponding angles postulate. It begins the same way my parallel lines postulate begins. If two parallel lines are cut by a transversal, then corresponding angles are, and now let's look at this postulate. If two parallel lines are cut by a transversal, according to my parallel lines postulate, if two parallel lines are cut by a transversal, all pairs of angles formed are either congruent or supplementary. So let's see, corresponding angles. Here I'm looking specifically at corresponding angles. So for example, let's say angle number 1 and angle number 5. That's a pair of corresponding angles. Well, it appears that angle 1 and angle 5, since they have to be either congruent or supplementary, it looks like angle 1 and angle 5, they both appear to be acute angles in this picture. So it appears that if two parallel lines are cut by a transversal, then corresponding angles are congruent. And in fact, that is the case. And so this is our corresponding angles postulate. Now, we have four additional, in this case they're not postulates, they're actually theorems, although they're worded very similar to the corresponding angles postulate. We're going to talk a little bit later about why these statements are theorems, and the previous statement on corresponding angles was a postulate. But for now, we're just going to fill in these blanks here for each one of these theorems. Now, again, we're going to make use of the parallel lines postulate, which says that if two parallel lines are cut by a transversal, and notice that each one of these theorems begins exactly that same way. If two parallel lines are cut by a transversal, according to my parallel lines postulate, each pair of angles must be either congruent or supplementary. So let's see if we can fill in each one of these theorems. The same side interior angles theorem says if two parallel lines are cut by a transversal, then same side interior angles are blank. So let's see. Same side interior angles would be, for example, same side and interior would be angles 2 and 5. That's a pair of same side interior angles. And I know they must be either congruent or supplementary. It doesn't appear that these two angles are congruent because angle 2 looks like an obtuse angle and angle 5 looks like an acute angle. So I'm going to say that same side interior angles must be supplementary. All right, let's go on to same side exterior angles. If two parallel lines are cut by a transversal, then same side exterior angles are blank. So let me find a pair of same side exterior angles. So let's see. Exterior, same side of the transversal. All right, how about angles 1 and 6? All right, do they look like they are going to be congruent or supplementary? Well, once again, angle number 1 looks like an acute angle. Angle number 6 looks like an obtuse angle. I'm going to say those two angles are not congruent, so they must therefore be supplementary. All right. The alternate interior angles theorem. If two parallel lines are cut by a transversal, then alternate interior angles are blank. All right, let me find a pair of alternate interior angles. Let's see. How about angles 3 and 5? Those are on alternate sides of the transversal and interior to the two lines, and they don't form a linear pair. So angles 3 and 5. So let me see. Angle 3 and angle 5, they've got to be either congruent or supplementary. Since they both appear to be acute angles in this figure, I'm going to say angles 3 and 5 are going to be not supplementary but congruent. And let's see my last one. Alternate exterior angles theorem. If two parallel lines are cut by a transversal, then alternate exterior angles are blank. So let's see. Let me find a pair of alternate exterior angles. How about angles 4 and 6? Those are on alternate sides of the transversal, exterior to the two lines, and they don't form a linear pair. So let's see. Angle 4, that looks like an obtuse angle. Angle 6 looks like an obtuse angle. So if these angles have to either be supplementary or congruent, I'm going to say that angles 4 and 6 are probably going to be congruent. So now we have, in addition to our corresponding angles postulate, we now also have 4 additional theorems regarding same-side interior angles, same-side exterior angles, alternate interior and alternate exterior angles that we can now use to solve some types of problems. So let's take a look at some of these examples. So here again, I've got a figure. I've got two parallel lines. I know they're parallel because I've got my parallel line symbols here. Cut by this transversal T. I've got my angles labeled 1 through 8. And for each one of these examples, let's see, and now each one of these examples, it says to treat each example independently. All right, so the measure of angle 1, if the measure of angle 1 is 58, what is the measure of angle 5? Well, I noticed from my diagram that angles 1 and 5 are corresponding angles. And since I have a corresponding angles postulate that tells me if two parallel lines are cut by a transversal, corresponding angles are congruent, that means if angle 1 is 58 degrees, then angle 5 must also be 58 degrees. Example number 2. Measure of angle 8 is 106 degrees. Here's angle 8. What is the measure of angle 2? So let's see. Angle 8 and angle 2, those are alternate interior angles. And I have a theorem now that tells me if two parallel lines are cut by a transversal, alternate interior angles are congruent. Therefore, if the measure of angle 8 is 106 degrees, then the measure of angle 2 must also be 106 degrees. Example number 3. If the measure of angle 1 is 67, then what is the measure of angle 6? All right, let's see. Angle 1 and angle 6 are same side exterior angles, and I have a theorem that tells me if two parallel lines are cut by a transversal, then same side exterior angles are supplementary. Therefore, angle 6 must be supplementary to angle 1. So let's see. 180 minus 67, that's going to be 113 degrees. Example number 4. The measure of angle 1 is 3x plus 7, and the measure of angle 5 is 4x minus 10. Find the measure of angle 1. Okay, so let's see. Angle 1 and angle 5. Here's angle 1, here's angle 5. Oh, this is a pair of corresponding angles. I know from my corresponding angles postulate that if two parallel lines are cut by a transversal, angles 1 and 5, corresponding angles must be congruent. Therefore, the measure of angle 1 and the measure of angle 5 must be equal. So I can say 3x plus 1 equals 4x minus 10. And I can solve this equation for x. So let's see, subtract 3x from both sides. X minus 10. And let's see, add 10 to both sides. And that gives me x equals 7. Now once I know the value of x, it tells me to find the measure of angle 1, so I'm going to need to plug that into this equation here. The measure of angle 1 is 3x plus 7. I plug in my value for x. So that's 21 plus 7 is 28, and the measure of angle 1 is 28 degrees. Now the last example here, number 5, says if the measure of angle 1 is 47 degrees, find the measure of all the other angles. Well, in order to do this one, I recall that back in the beginning of this video, we had a postulate called the parallel lines postulate, which says that if two parallel lines are cut by a transversal, and I'm going to let you finish that and fill in the rest of example 5 on your own, and we'll talk about this some more in class tomorrow.